Japan has become the 5th country to land a spacecraft on the moon, but some complications have put the rest of that mission in jeopardy.
There's an interesting picture on the moon that does appear to show something that could be a bridge, maybe a pipe, could be an inching worm.
Japan's cutting-edge Moon Sniper mission has just sent back data that left NASA stunned. What it found on the lunar surface was completely unexpected, and it could change everything we know about the moon. For decades, scientists believed they had a solid understanding of this region, but Japan's slim lander, designed for pinpoint accuracy, just proved them wrong. The discovery has sparked intense interest from NASA, raising serious questions about what we might have overlooked in previous missions. But what exactly did Japan's lander find, and why is NASA suddenly so interested? Japan's Smart Lander for Investigating Moon, SLIM, better known as the Moon Sniper, is one of the most advanced lunar landers ever built. Unlike previous landers that could only approximate their landing sites within kilometers, SLIM was designed to touch down with extreme precision, within just 100 meters of its target. This marks a major leap forward in lunar exploration, allowing scientists to access previously unreachable areas with pinpoint accuracy. The mission, launched by JAXA, Japan Aerospace Exploration Agency, serves as a demonstration of next-generation landing technology. This capability is crucial for future space missions, particularly as NASA and other agencies prepare to establish lunar bases under the Artemis program. Artemis will require high-accuracy landings to ensure astronauts and robotic explorers can safely reach resource-rich sites for sustainable lunar habitation. But SLIM's significance goes beyond just technology. It signifies Japan's growing influence in space exploration. While JAXA has conducted successful robotic missions in the past, including asteroid landers and lunar orbiters, this mission is different. SLIM is actively scouting the moon's surface, analyzing terrain, and uncovering new data that even NASA hadn't anticipated. With Japan stepping up its lunar ambitions, NASA has been watching closely. A lander with this level of precision could be a game-changer for future Moon and Mars missions. But as it turns out, SLIM's mission wasn't just about landing, it's what it found after touchdown that really shocked scientists. As soon as SLIM began analyzing its surroundings, its onboard instruments detected rock formations that didn't match any previously known lunar geology. These unusual formations raise major questions about the Moon's history and how its surface has evolved over time. Some scientists believe they could be evidence of past volcanic activity that wasn't accounted for in earlier models, while others suggest they might hint at something even more mysterious. But that wasn't the only surprise. SLIM's sensors also picked up unexpected signatures deep in the regolith. Early analyses suggest the presence of a metallic anomaly buried beneath the surface, something not accounted for in any past lunar studies. Could it be remnants of an asteroid impact or something even stranger? Then came the most shocking find of all, possible signs of water ice in an area where scientists never expected it. If confirmed, this would be a major breakthrough, redefining how and where future missions search for water on the moon, critical for long-term human presence. NASA has studied the moon for decades, so how did they miss this? Was this region previously overlooked, or are our lunar maps incomplete? If SLIM uncovered something this significant, what else could we have missed? More importantly, what does this mean for future Artemis landings? SLIM's groundbreaking discoveries weren't just lucky observations, they were made possible by advanced imaging and scanning technology that previous missions didn't have. Unlike older landers that primarily relied on surface cameras and limited spectrometers, SLIM was equipped with high-resolution optical sensors, infrared scanners, and precision altimeters. These tools allowed it to map the terrain in unprecedented detail, uncovering hidden features beneath the lunar surface. One of the biggest questions now is whether the moon has more geological activity than previously thought. The unexpected rock formations detected by SLIM could be signs of ancient volcanic activity or even remnants of an asteroid impact that changed the lunar landscape. If that's true, our understanding of the Moon's history could be fundamentally flawed. For decades, NASA has mapped and studied the Moon, but SLIM's discoveries suggest there are still major gaps in our understanding. One key reason: previous missions lacked this level of precision. Most past landers and rovers touched down in relatively safe, well-mapped areas, avoiding rough terrain or scientifically unexplored zones. SLIM's pinpoint landing may have given scientists their first look at a completely unexamined region, one that could rewrite lunar history. SLIM's discoveries aren't just a scientific breakthrough, they could change the entire future of lunar exploration. If the Moon has unexpected materials beneath its surface, this could directly impact future human settlements. The Artemis program and other lunar missions have long assumed that specific regions of the Moon would be ideal for colonization. But what if the most valuable resources are in places we never even considered? For example, if SLIM has detected water ice or valuable metals, it could transform how we plan long-term lunar bases. Water is a crucial resource for human survival, rocket fuel production, and sustaining life beyond Earth. If Japan's lander has identified new locations for these resources, it could reshape how and where future colonies are built. But the implications go even further. What if the materials found suggest a previously unknown chapter in the Moon's history? If these rocks don't match what we expected, it could mean the Moon's formation process was far more complex than scientists originally thought. This could lead to a major revision of lunar geology and even impact theories about how the Earth and Moon evolved together. With these game-changing discoveries, the question now is, will NASA and JAXA collaborate more closely in future missions? Japan's success with pinpoint landings could make SLIM's technology an essential tool for future Artemis landers. If NASA integrates JAXA's precision landing systems, it could allow astronauts to safely reach new regions of the Moon that were once considered too dangerous to explore. With every new piece of data, it's becoming clear, this mission didn't just prove precision landings work. It may have uncovered something that changes our entire approach to lunar exploration. Japan's Moon Sniper mission has already made history, proving that pinpoint landings are now possible. But perhaps more importantly, SLIM's discoveries have revealed that NASA may have overlooked something crucial about the Moon's geology. This mission is forcing scientists to rethink their assumptions about the Moon's surface, its resources, and its history. If SLIM's findings hold up, future lunar exploration plans could change dramatically. Artemis landings, resource extraction, and even long-term Moon bases may need to be relocated to areas we once ignored. But this raises an even bigger question: if NASA missed this, what else could be hiding on the Moon? Could there be even more surprises waiting beneath the surface? Could the Moon hold secrets about our solar system that we never even considered?